let's see, number 4. This is what confuses me, knowing this one. So I just guessed on this one, but.
Oh, 4 types of one.
Oh, wait, maybe I didn't. Actually, I did. I did the 3rd one, actually.
So the 3rd one is the distribution of the mean of each sample is normal. Since the data.
Oh, are you on number 3?
So the number 4 is confidence. The confidence interval for the difference of means using independent samples.
Yes.
Yeah.
Because it was males and females. But other than that, they weren't related at all. Okay, number 5. What do you think about this one?
Yeah, I'm trying to get so this is saving accounts of random sample 30 customers.
Mm-hmm. So to make it smaller margin of error, wouldn't you just get a bigger sample? That's what I put. Obtain balances of 90 rather than 30.
That makes sense. I mean,
that's what I thought.
I was just confused between the 99% confidence and the 95.
Mm-hmm. Well, I guess we'll see if it's wrong. I'll let you know. I'll submit it first.
Yeah.
Makes color dry shaft for shift. Margin of error. So I think this one, number 6. Are you on number 6?
Yeah, number 6. Yeah, I'm trying to see how to calculate it.
Oh, okay.
But yeah.
Yeah, you calculate it and see if we get the same answer.
Because I was thinking to use the Excel, but.
Oh, no. So I think that margin of error is the Z times standard deviation over square root of n.
The standard deviation is 2. What number you got?
For the margin of error,
Yes.
1.96. What did you get?
I was looking for the mean, how to get the mean without getting.
Oh, sorry, the Z, when I say Z, it's when you plug in the 0.95 into the normal split. So that's 1.96, right?
Okay.
And then if you multiply it by, did you get the same answer?
Yes. Now makes sense. I was thinking as to how I get the.
Yeah, it took me a minute to find that one.
Oh, okay.
Okay. And then to get the lower bound, you just subtract that from 1,000.
Is we just added.
What?
And the upper bound is we just added.
Yes. So what'd you get for those two?
Lower bound is 998.
0.040?
Yes.
Yeah.
104. But I can put 0. Let me round. And then the upper is 1001.96.
Yes. That's what I got. Okay, so this one. Do you know what test to use for this? Because I didn't. So I had to look it up.
That should be. I think this is on the Excel sheet we got the first one.
For number. So this is a formula that we use. And it is.
I remember there was a question number 3.
We're on number 9, right?
No, I know. I'm just saying. I remember one of the quizzes we did. It was a question number 3 that had the same thing here.
Oh, really?
Yeah, I'm just trying to
figure it out with this one.
Yeah.
So this is the sample size formula. And it's Z times standard deviation divided by the margin of error. And then all of that squared.
Now let's put the math.
Did that make sense?
Yes, I just have to. And then, the Z-score, we get it from the offlet because I was looking something online and said they had this table. I was like, where this table is? There's people going through this table.
Uh-huh.
And then it was it was a small difference on the number. It wasn't pretty much the same, but it was a small difference.
Oh, really? Oh, that's weird. I just use the applet because
And that's what is given to us. So
the easier. I think it's easier. Okay.
95. One. So this was 1.96 times 0.01 divide.
Yes.
This divided by 0.00.
Mm-hmm.
Square root of.
There's 3 zeros, right? 0.0001.
Yes. And then it's the square root of 196. Why is not giving me square root?
Oh, not square root. You look that. You put it in parentheses. Can you see my paper? And then square it.
Oh, okay.
That's what I meant. Is that what it's called? Square? You square it?
Yes. Well, yeah, you square it. Or second power or something.
There you go. That's what I meant.
So do you get like 38,416?
Yes. Yep.
Oh, okay.
Okay. Oh, since they think it's smaller, the alternative hypothesis would be the mean is less than 1250, right?
Can spell without knowing the size of cell by using it. Yeah. Oh, okay. Well, the question is, I don't. Oh, okay. Which? Oh, I see. I see. So yeah, small things that apartments are smaller than advertised. So yes.
So then the less than. Okay, so the last one. All right.
Yes. I mean, they're different. Even the first one can stay because if they're not 1250, they're different than 1250, but they think it's smaller, so.
Yeah, because that not equal to would be the two-tailed. So, yeah.
So it'll be not equal, smaller than.
What?
Now just say not equal and smaller than 1250.
Yeah, not equal would be smaller or greater than 1250.
Yeah.
So those ones confuse me. I think I'm gonna get confused during the test for that one.
Probably.
Okay.
I think it's like the key is to read the question a couple times.
That's true. I need to do that. I'm really bad at that. Okay. So next one, if the P is low, reject the null. So yeah, it's the second one.
Yep. The data from each apartment is bell-shaped. Are nearly equal. I think yes.
The only thing that confuses me is that in ANOVA, the one with the means for several groups, is this several groups? Oh, never mind. So it's the fourth one then, right?
I thought it was the third one.
Third, yeah, sorry.
Yeah.
Okay. So I got that one wrong. Okay, medical.
That's a long question.
I know. Consequently, she rejects the null. So if you reject the null, that's a type 1 error, right? What?
Yeah, trying to understand, like, he checks the null. Yeah, but she has like it's a small group. She cannot that.
That's true. But so in that case, what would it be? Because you can have a small group, right? It just has to be normal. But
I mean, to use this conclusion statistically, I think for future she need to get the p-value.
that makes sense. Incorrectly. That's true.
I mean, for future, for this particular case, she was fine. But if they want to use this treatment every time, they need to conclude a more accurate study.
Mm-hmm. So do you think it's the first one or the second one?
I was thinking the second one.
Okay, let's go with that.
Okay, as I said, your guess is equal as mine.
Maybe I'll do the first one and you do the second one. I'll tell you if the first one's wrong.
Okay. Okay.
The level of significance is made very soft.
Well, then I have no clue here.
What?
I have no clue on this question.
Which one?
The 14?
Well, so my logic was you're either going to reject the null or you're going to fail to reject the null, right?
Yes.
So if you if you're more likely to reject the null and make a type 1 error, they're like inversely related, you know? So I think by reducing the probability of committing a type 1 error, we increase the probability of committing a type 2 error.
Yeah.
So I think it's the first one.
Okay. How you explained made totally sense.
Oh, it did? Good. That's how. It took me a minute to figure that one out. Hopefully it's right, though. You're going to give me way off.
Yeah. We shall see.
Yep. Okay. Sample. Tell me when you're done reading it.
Oh, yeah.
Oh, you are? So
Yeah.
I didn't know what to do for this one. I just plugged it into the T distribution formula. But I don't know if that was right.
So when you can do reject the hypothesis. Okay. So I was thinking this at 0.05. That was significant.
So I did T equals 1.53 minus 0.5, and then all over 0.17 over square root 100. And that's the T distribution. Sample standard deviation. Do you get what I'm saying?
If we had the mean, it'd be easy if we had the mean. Wait a minute, the mean is 1.5, right?
So yeah, that's the population mean. So I did the sample mean minus the population mean all over standard deviation over square root of 100 n.
Yeah, because we can use the Excel for this one.
We can.
I think so. Now let me try. I mean, the p-value is 3 point something. So.
I got the p-value, or I guess I got the p-value of 0.018.
Yours is probably better than mine. Mine is 3.1.
That's what I was thinking. But do you get what I'm saying? The t-distribution test, or the t-test?
Yes. Okay, I'm trying.
Null hypothesis.
Well, let's take your p-value. So was 0.
Oh, 0.018. And so it was lower than the level of significance.
But the significance is 0.05.
That mine is 0.018.
Oh, okay.
Mm-hmm.
So we failed to reject?
Yes. Wait. What number is this?
The question 15.
Okay, that's what I thought. Because if the p is low, reject the null. So don't we reject the null? Because it's lower than the level of significance.
Yeah, if the p, we can get confused for this is easy. So let's go back to the basic. So if the p-value is lower than the level of significance, means that we reject the null hypothesis, right?
Mm-hmm. Yes.
Okay. So I made a mistake here then.
Okay. Like you said, they're all so close.
Yeah. Okay. Okay. So it was the fourth one, right?
Yes. That's what I put.
Yeah. And you would like to know the
What?
This is the question 16.
Yes. Tell me what you think, and I'll tell you if I thought the same.
I'll say paired sample.
So I think it's dependent samples.
Yeah, it can. I mean, girls and females and male can be independent, but
Well, they're not
the same company.
Well, they're not dependent because if you pick one certain male, you're not going to necessarily pick one certain female.
Yeah.
Whereas, like, if you're picking a brother and sister, that would be dependent. But I think this one is independent. This paired sample is when you have two samples from one test group, right?
Yeah. No, I was thinking they work for the same company, but no. It's here that they depends how. No, I was reading incorrectly.
Oh, okay.
I thought they were doing the hours work wage for this company, male and female.
Oh, yeah.
And I was like, well, it's kind of dependent because they're in the same company and.
Yeah, that would be confusing.
But yes, independent, yeah, because it doesn't really matter the hours the male student works with the hours the female student works.
Mm-hmm.
But I can tell you the female will have higher grades than the male.
I don't know.
Yeah, this is dependent.
Mm-hmm.
And I think it's the fourth one.
Yeah. That's what I put too.
Okay.
Okay, so this is the one where I got super confused. This is number 15 on the text.
Yeah.
I think Abigail is going to have one.
Yeah, I was reading her email.
Oh, did she send an email?
Yeah, she said if I make it to a destination, I'll hop in.
Oh, yeah. So I think I sent her the link that she just asked me.
Yeah, probably.
Okay. To your email. Okay.
Yeah, this is the question we were discussing earlier.
Yes. Yeah. So I'm stuck on 18. Yeah, on 18, and then how to set it up.
And how to find it is known or unknown.
Yeah, I don't know, because I mean, once you plug it into our Excel that we can use, you know everything. So I'm assuming that it's unknown because I don't remember why, but I had a thought.
And this is just one variable. We don't have.
Yeah. So you think it's unknown too?
It's just a guess.
Oh, okay. We'll put that and then go to that if we get it wrong. Okay. So we need to put it into our Excel. Do you have that Excel open?
Yes, but.
So it's the one sample t-test, right?
Yes.
Okay, so what do you put for the null?
The 0.
That's what I mean. That's what I was.
That's what I had always there. So.
Okay. Okay, so then margin of error. I have 0.967. Is that what you have?
Well, that's the thing though. We have to put a mean there, and my mean here is not connected. That's weird.
What's wrong?
No, I mean, on my Excel here, the mean is not connected with the variables. You know, it just gives you the mean right away.
Yeah, it's not.
It's not. I just have to make a formula.
Here's the formula I had in there.
And to download this is taking forever. Okay.
I think Abigail's hopping on. Okay. So were you able to get it?
Okay. Yep.
Good.
Do you get the mean 13.193?
For the mean, yeah.
Oh, okay. So I connected right. Yeah, I had to put a formula there because that cell didn't have it. I don't know why.
Okay. So for standard error of the mean, do you have 0.967?
Standard derivation. I can check.
What?
Even my standard deviation was not showing up, but I can put the formula here.
Maybe you should just get a new copy of that Excel.
Yeah. So 0.865, you said?
No, I have 0.967.
Let's see, where did I messed up? Yeah, I should get a new. I'm curious to see where do I messed up. Confidence there. I don't know. Just wait a minute. What you got for the lower the confidence of interval?
11.168.
11.407.
That's not a that's not a choice because
Yeah, I wonder where I messed up something on the formula. Because the the difference is so small, but I wonder I messed up somewhere.
Yeah, that's weird.
Oh, okay. I can fix it. So let's go with your numbers. Your margin of error was?
Sorry, 0.967. I don't know if that's right though. Is the margin of error the standard error of the mean?
Oh, I gotta have this.
What?
No, I have another group meeting soon. No
Oh,
worries.
you do? Okay.
But, no, I understand. So you're saying the standard of error of mean, which is the standard deviation.
The standard error of mean, is that?
The square root of this.
Is that the margin of error?
No, the margin of error is the between two confidence of interval. We add them by 2.
You what?
We add them together and we divide them by 2.
Oh, right. So 11.168 divided by 2. So for margin of error, did you get 13.193? That can't be right.
I have different, as I said, different confidence interval here since I don't know where I did that mistake. So.
Oh, okay. Okay.
The lower bound is
168. Then the upper bound is 15.217. How long to your next group meeting?
5 minutes, but I'll tell them I'll be late. So.
Okay.
So we're in question 22, right?
22? Yeah.
Oh.
Is that what you said?
Yeah.
Okay.
The hammers.
Yes. Okay. What? This one is independent samples. Right?
Well, there is a price between. I mean, they depend on the car, and the car goes. That's the thing, though. If you buy, let's say a Hummer, or let's say a Ferrari, if you buy it in LA or New York, the Ferrari is gonna have the high standard car too.
Mm-hmm.
The difference can be like $1,000 to $1,000, but not that much. So the salesperson in New York with a salesperson in LA gonna have listing to the same price pretty much. Not, may vary a little bit, but not that much.
Yeah. So
it's not that you can go to LA and buy the Hummer for $10,000 less than you buy it in New York.
that's true.
So they're dependent,
But they're not dependent on each other like who they choose.
yeah.
Well, I mean, they're not matched pairs. I think they're independent. Go with that. If you need to go to your other meeting, I'm totally fine doing this.
Yeah, I'm just. Yeah, the rest of the questions are just plugging the numbers. We just have to decide which formula to use.
Yeah. I'm going to look that up a little more and figure that out.
We use independent samples.
Difference in mean.
We do a 2-sample test. That probably solves the problem.
That's what I was thinking too, the 2-sample t-test.
Yeah.
Oh, yeah. 95. Okay. For 23.2. So I think I just plugged all that in, and the lower bound I got negative 423.238.
That doesn't sound right.
What?
Negative?
Yeah. Maybe because it's less than.
Wait a minute. Well, our hypothesis is that we have to find if the price is different, you know?
Mm-hmm. Yes.
So it'd be not equal to.
Yeah, for the type of test.
Yeah.
That's what I put. Oh, sweet, we're almost done. So what number are you doing?
Yeah. No, I mean, I didn't plug this, so I was like, let's get over it.
Oh, yeah.
So yeah, we can look the 25th one.
Okay. Do you want the number for the upper bound and lower bound or no?
Okay. Yeah.
So for lower bound, I got negative 423.238. And upper bound, I got 5417.336. You go to basketball. All right.
I'm gonna be so sick tomorrow.
I know. Okay, bone density. There's 3 groups of rats. Oh, this is the ANOVA, huh? For 25?
Yes.
25. Okay, so ANOVA. Control.
I remember.
Low jump. What did you say?
No, I was looking at the next question, and I remember this from the homeworks.
Oh, yeah.
Yeah.
I have the photographic memory.
Sometimes I don't remember the whole answers, but I remember I did this question.
Yeah.
Which one was the answer? The conclusion.
Oh, you remember?
Yeah. Which didn't make sense for me when I did this, but I thought I was doing the wrong hypothesis.
Oh, really? Low jump. We've already done this?
Yes, like the 90-day. The last question, let's do the airplane tickets. And there's a difference in price between 90 days ahead or 40 ahead.
Yeah.
In real life, it is a difference. So we don't need to do a study to know this, but when we study,
Mm-hmm.
p-value it's greater than the level of significance, and that means that we had to reject the
null.
null. And the null was if they are the same.
Oh, yeah, because we're seeing if one of them is different, right?
Yeah.
Enova, let's see. Oh. Abigail's trying to log on right now.
Oh, okay. So I'm not gonna feel guilty if I leave.
Oh my gosh, you don't need to feel guilty at all. Yeah, you can totally go. You didn't need to stay.
Okay.
Yeah, I feel pretty good about these last ones. So thank you for meeting.
Okay. Well, good luck on the exam.
You too. We'll talk next week.
Thank you.
Okay, thanks. Bye. Wait for Abigail.